Hello guys, I'll be talking about the Doppler effect. Now I'll be using some pictures, an Android app and some posters to explain this concept. First I'm going to talk about these waves in the water. The source of these waves is this duck in the water. When the duck is stationary, the waves are evenly spread out. And when the duck starts moving in one direction, as you can see in this picture, the waves ahead of the duck are more compressed, and at the rear end, the waves are more spread out. So if I have to draw a diagram, it would look something like this. This when the source is stationary, and this when the source is moving in one direction. If there is an observer standing ahead of the moving source, he receives the waves at lower wavelength or higher frequency, and the observer behind the moving source receives the waves at higher wavelength or lower frequency. Now, higher the speed of the source, greater will be the change in frequency. So this change in the frequency of a wave because of the relative motion between the source and the observer is the Doppler effect. Now the same phenomena is also observed in sound and light waves. In the case of water waves, the source is the bird in our example. In the case of sound waves, the source is a source of sound like a moving vehicle. In the case of light waves, the source is a source of light like sun or other distant stars. Now in the case of sound, the Doppler effect is observed as a different pitch than the original pitch of the sound. Let's have a look at this moving police vehicle. As you can see, as the vehicle is approaching towards the observer, the pitch is higher. This is similar to an observer standing ahead of the moving source, receives the waves at higher frequency. That's why the pitch is higher. As the vehicle is moving away from the observer, the pitch is lower. This is similar to an observer standing behind the moving source, receives the waves at lower frequency. That's why the pitch is lower. Now in the case of light waves, the Doppler effect is observed as red and blue shift. Let me explain. So when we talk about light, we talk mostly in terms of wavelength. And the visibility range of a human eye is roughly from 400 to 700 nanometers, which is actually a very tiny part of a big electromagnetic spectrum. This is the only region that is visible to our eyes. Most of the light from sun and other distant stars are invisible to us. Now say for example, there is a source of light emitting light within the visible region, say 580 nanometers. So I have an Android app that gives the color of a light corresponding to a wavelength. Say 580 nanometers of light appear yellow to us when the source is stationary. Now say when the source is moving away from us, then the wavelength increases, say by 20 nanometers in our case. So 580 becomes 600. So 600 nanometers of light appear orange to us. And if the source is moving towards us, then the wavelength decreases, say again by 20 nanometers. So 580 becomes 560, and 560 nanometer of light appear green to us. So when the source is moving away, yellow becomes orange, or it is moving towards the red end of the spectrum. This is called redshift. And when the source is moving towards us, yellow becomes green, or it is moving towards the blue end of the spectrum. This is called blue shift. So red and blue shift are commonly used terminology in science when talking about Doppler effect in light. Red shift doesn't mean that the light will appear red. Blue shift doesn't mean that the light will appear blue. They're just another ways of saying if the wavelength of a light is increasing or decreasing. Now, the Doppler effect in light can be used to prove that our universe is actually expanding. One of the famous scientists of all time, Edwin Hubble, in 1920s, while he was analyzing lights of distant stars and galaxies, observed redshift in the spectra, and he actually proved that all these distant stars and galaxies are actually not stationary, but they are constantly moving away from us. And if that is the case, then the universe as a whole is not static as it appears to be and as it was assumed to be, but is actually constantly expanding. Hope this helps. Thank you very much.